All right, so for these two examples, we're going to be doing some comparing. So it says Eli invested $37,000 in an account that has an interest rate of 6.75% compounded quarterly. Then it said Xavier invested $37,000 in an account that has an interest rate of 6.14% compounded annually. After 9 years, how much more money would Eli have in his account than Xavier to the nearest dollar? So we're going to be comparing two different people in two different accounts. So we have Eli and we have Xavier. Now, Eli, he compounded 6 3/4. So I would definitely convert my 6 3/4% to 6.75%, so we can deal with that. And this compounded quarterly, so we're going to be doing the compounded formula. Xavier, he did 6.25%, and he compounded annually. So his is n equals 1, or really we don't have to plug in 1 because it's not going to change anything. So we're going to be using our compound formula. And remember, our compound formula is P times 1 plus R over N raised to NT. And we're just going to see how much more money Eli would have. So I have A of T, my initial value is 37,000. 1 plus my rate is going to be 0.0675 over 4 raised to 4 times, and the time is 9 years. And I'm just going to plug that straight in. And we have 4, and we're going to raise that to 4 times 9, or 36. We'll just go ahead and convert that to 36. So Eli has approximately 67,582.50 in his account. Now, we're going to do the same thing for Xavier. We would change his interest rate. So we have A of T. He still has 37,000. And we have 1 plus, this is going to be 0.0625 over 1. You do not have to do it over 1 if you don't want to. You can just leave it like a normal formula. But I'm going to go ahead and convert all of that right in Desmos. And so like I don't have to retype everything. And this is going to be 9. So we have 63,850.19. Now, it says how much more would he make to the nearest dollar? So we would just simply subtract them here. So we have 67,582.50 minus 63,850.19 to the nearest dollar. So he would approximately have $3,732 more. All right, so then it says Kaylee invested $860 in an account paying at a rate of 6 1/8 compounded annually. Gabriel invested $860 in an account, and he would pay an interest rate of 6 1/2% compounded continuously. All right, so we have Kaylee, and we have Gabriel. So we have 6 1/8. So if I do 1/8, that's going to be 6.125%. He's compounded annually, so n equals 1. Gabriel, he's 6.5%, but he's compounded continuously. So we're going to be using a different formula here. We're going to be using our continuous formula. How much more money would Kaylee have in her account than Gabriel's money if Gabriel's money has tripled in value? So we're going to actually have to use Gabriel's information in order to figure out Kaylee. All right, so we want Gabriel to triple. So what are we missing in this problem? If you notice, they didn't give us any time value. So we're going to have to use Gabriel's information and solve for t. And then after we solve for t, then we're going to use that t and figure out Kaylee's information based off of that time. All right, so if we want to triple here, we are going to be looking at our ending value. So Gabriel started with $860, and he wants to triple to $2,580. So remember, Gabriel was compounded continuously, so we got a lot of information that we need to make sure we organize. So he is going to $2,580. He started with $860. E raised to K, which is going to be 0.065, and T. So once again, we're going to solve for T, and then we're going to use the T, and we're going to apply that time to Kaylee's information. All right, so we're going to divide by 860. So we have 2580 divided by 860, which is going to be 3, equals E raised to 0.065t. Again, I like to use the natural logarithm and do my inequality rule just because it's going to be easier to cancel and solve. All right, so that's going to cancel, and then we're going to divide by the 0.065. So we have the natural logarithm of 3, and that's going to be divided by 0.065. So my time is approximately 16.9 years. So now we're going to use that time, and we're going to apply it to Kaylee. So Kaylee is compounded annually. All right, so we have A of t, because we're going to actually be solving for Kaylee's final value. And it's going to start out with the initial value of 860, 1 plus my rate of 0.06125 over 1. And then we're going to raise it to 1 times 16.9, because we had to use that time in order to calculate her stuff. So we have 860 times 1 plus 0.06125 divided by 1. You don't have to divide by 1, just like you don't have to raise it to 1 times that value. But I'm just showing you where everything kind of goes. So Kaylee's final amount is going to be $2,348.65. So the question was, to the nearest dollar, how much money would Kaylee have in her account when Gabriel's money has tripled? So Kaylee would have a total of $2,348. So just to walk through this again, we use Gabriel's information and we saw for the time it would take him to triple. Because in order to figure out Kaylee, we had to have a time in order that was relating to Gabriel's value of tripling. So once we solved for Gabriel, we got our time, we plugged it in for Kaylee, and then we found out Kaylee's amount during that time frame.